So the outline of this talk, I want to give a moment of real appreciation for DHIS2. It's been a game changer for us, but I want to point out why that in and of itself isn't enough for us to really make the decisions that we need, to use the data. And so I'm going to walk through a web-based app that I built to help fill those gaps. So I was saying, like, here is trying to do a site visit to a health facility that was actually about a 2-day drive away from the capital city. And yet, and so far away that our wheel fell off. And, and about a half hour later, a moped came by with a guy holding the lug nuts that he had found along the street. So even after this, George, we get to the, oh, sorry, I back up. Oh, it passed one. So we get to the facility and there's all this cheering and they can't wait. I'd like to say, they want to tell us that they're so, there they go, they're so happy that they have DHIS2. I think if you download the talk itself, you can actually play that little video. But just to go back, I mean, we used to have to go to look at these registers on paper, and now we have all this data electronically. Okay. So having easy access to health facility data is a game changer, but it turns out that just having that data by itself, and what I'm just going to use as some raw data, isn't sufficient. And in part, it's because it doesn't allow us to do kind of the rigorous analytic plan that we need, which means documenting what data has been included in what's being shown, controlling for reporting bias, which I'll describe in a little bit, removing outliers, and then using some time series modeling to really understand the change in data. Okay, so if we want to do more with than can be currently done in DHIS2, we've incorporated an app called Magic Glasses 2. This wasn't actually my name. It was a partner that we work with, just couldn't believe that they could now see things they couldn't before. So they gave it that moniker. But the idea is a country has its own DHIS2 instance, but that has an API that allows us to access that data through code written in R Studio. We then built an app within R that is a shiny application called Magic Glasses 2 that is able to draw out the metadata, the data you want, do data manipulation, visualizations, and time series analysis, leveraging those all the packages that are written in R. Okay. So here is a screenshot of the shiny app. It's web-based, and along the top, there's basically 6 pages that allow you to go from the setup to the analysis. Okay. So just walking through that, you start with a setup page where you decide where you're going to be storing your data, and you provide your credentials for the instance that you're looking at. All of this is stored locally, whether or not this is run on a server or not. It does not go to the server. It's just stored for whoever the user is. Okay. So once a person is logged in, we go to a metadata page where you can fetch all of the metadata from the system. Okay. Interesting thing is, while administrators can see the metadata, those of us who actually want to use the data can rarely see it. So most end users can't find out what's in that metadata unless there is perhaps an external app that's been added to DHIS2. And in the countries that I have direct access to, only 3 of those countries actually had a metadata app. And so for the remaining 8, there was no way for them to look up any of the metadata. And yet, all of that metadata is actually available to end users if you use the API. So it's great, but the problem is the API returns it in XML. But so what our app does is it just translates that in a way that's easily readable. So here's an example. Here's all the data elements. Many of our countries have as many as 10,000 data elements. So, you imagine if you're using a pivot table and you're trying to find the data element you want when there's only like 6 or 7 visible, how are you going to, really know that you've got what you want? So we encourage people to try and look things up here. We've got a number of search fields. where you can search by the name, the data set, the period type, is it a monthly element or not. Similarly, we have a list of all the data sets to help orient people, and the indicators where the numerators and the denominators are spelled out so you can see exactly what's included in them. There you go. And for the org units, we have an org unit hierarchy. So for instance, if somebody tells me there's the Embala clinic and I wouldn't know where that is, I can look it up here and find out that's a part of which district, which province, etc. And then it's mapped as well. Yeah, we go into the next phase. Step 3 is actually, let's say I want to look at confirmed malaria cases. There's a lot of ways of pulling out confirmed malaria cases for most of our instances. So I need to know with certainty what is being pulled. For instance, does it include outpatient cases? Does it include the inpatient cases? Does it include the community health workers? So I need to have that documented. So if somebody shows me just a list, here's a chart with confirmed malaria cases, I'm not certain what's been included. And especially over time, it can depend on who's pulling the data. So this actually documents it, and that's saved. And then once that's saved, you can select a time period for looking at that data, press the request data button, and then the API goes and fetches all that data for each data element and category combination for each and every org unit in the entire set. So not by district, but actually by facility and all the way up, because that's the data, it turns out, that we really need. So once that's done, at this point, the app can be completely offline. You can reuse that data set. So you don't, so for countries where there's problems staying connected, you can find a time when you're connected, get your metadata, get your data, and then after that, you're free to explore your data on your own without connection. The next thing we want to look at is the reporting. And so this is the reporting page, and I want to go into this in a little bit of depth because it's one of the really critical things in making the best use of data. So let's talk a little bit about reporting bias. As we all know, the data starts on a piece of paper on the left, line list of the patients that come in and their conditions. And that gets somehow, summarized and put into an electronic format. Errors happen. We all understand that there is going to be some problem there. And countries spend a large amount of their resources trying to assess facility data quality, to being sure that that translation from the paper to the electronic format is good. But the interesting thing is there's actually potentially a much greater problem that is almost always overlooked. So with all this emphasis on data quality, did they go from paper to electronic? Okay, we miss the fact that that electronic data can be misleading. And let me give you an example of what can happen. I just pulled here a county that has endemic malaria, and it turns out this was for August 2001. It was typically a time when there's a lot of malaria in that district. And so I pulled out the values for the first attendance to all the outpatient facilities, the number of persons with suspected malaria, the number of those that were tested for malaria, the number that had confirmed malaria. These are the key data elements we would look at to assess the case management within health facilities. So one of the first things we usually look at is we can compare, okay, what percentage of the patients had suspected malaria? And in not just in a place where there's endemic malaria, but pretty much anywhere, one of the main reasons for going to a health facility is having a fever. It may or may not be malaria, but we try and advise the clinicians that if there is a fever, please test for malaria. Now, this surprises me that only 14% of the patients came to the facility with had suspected malaria. And that's a concern that perhaps the clinicians are saying, oh, it's a fever, but we don't think it's malaria. And therefore, maybe they didn't test. We want universal testing of all fevers. So we then look at another indicator of this. Okay, of those that they suspected for malaria, what percentage of them were tested? Our entire budget line is predicated on making sure that every facility has a test for every febrile patient. And this is a high priority district with malaria, and only 35% have it. Very concerning. But then of those that were tested, 126% were positive. All right, so crisis mode. This data, what's going on? Okay, and they said, well, maybe we should go. It's that outpatient clinic. It's chaos. Let's go to the laboratory. Well, that's a real number, 13%. Although actually, I'm a little suspicious of it, and because it turns out there's 4 times more persons tested in the laboratory than there were according to the outpatient data. So that seems a little off. Okay, let's look at this data a little bit with a little more information. It's that same data before, but okay, could there be a reporting problem? Well, I'll go to the data set that's used to report this data. There was 261 facilities that were expected to report in August. 253 supplied that data set. It's a reporting rate of 97%. So it looks like we got all the data, right? But if I look at the data element reporting, meaning how many of those facilities actually provided data on first attendance, I see that 219 did, which you may notice that means there was a number of forms that were submitted without providing data attendance. Only 158 of them included data on suspected malaria, only 76 on the number tested, and 143 on it. So once you look at it this way, you can see that when you start doing those ratios, that ratio of percent suspected malaria is a huge underestimate because the numerator has far fewer facilities than the denominator, and all the way through. So that reporting rate that is often used, that data is, I shouldn't say it's not real. It is real. That's the number of forms that were provided, but it's not useful for us because that doesn't capture the actual data that's there. So how are we going to use this to drive our program? And I'll just point out that this is something I see repeated in many of our countries. And it's because those forms are so large, and there's pressure to get them submitted on time. And what will often happen is they'll at least fill out they're in a hurry. I'll fill out the big items like total attendance. They want credit for that. Or maybe more so confirmed malaria, but they leave many other boxes blank. And this happens pretty much anywhere. So the problem is that any indicator, though, using a ratio of these values is no good unless you can somehow adjust for that reporting. And yet that reporting rate is not easily visible within DHIS2. Right. So our app is, so while I was looking at ratios there, if you're looking over time, there's a very analogous problem. So in this page of the app, I'm showing on the top some information about the number of facilities that we're reporting. And the bottom chart is the number of confirmed malaria cases. And just to highlight that, just to guide you right to it, I'm just drawing a line here, which shows that on a 5-year trend, there's a pretty significant increase in cases. But are these cases really increasing? So we want to look at is the reporting. And in these top charts, there's a top black line that shows the total of facilities that could have reported. The black dots are the number of facilities that did report each month. So you can get a sense of what that reporting rate is. But it turns out that's not the whole story. And so I also want to look at the histograms that are on the right. Each of those boxes is a year. So for instance, in 2017, there's a histogram there where on the far right, those are the number of facilities that reported for all 12 months. And you can see that this is the majority, and then there's a number that only reported 11 months, et cetera. Okay? But at most, only about 10,000 facilities of the 20,000, only about 10,000 of them reported for all 12 months of the year. And that was in 1 year, but they didn't do that year after year. So actually, if we search for those facilities that provided data each and every month along this time period, only 25% of them provided that data. So there's clearly could be a lot of reporting bias here. So one way that we've hit about it's like, what if we want to see the true signal? Well, what we could do is we could potentially remove the reporting bias by just restricting our analysis to those facilities that did report every month. And so Here, the app is built in to show you two different graphs. The one on the right is the chart of the confirmatory cases for the facilities that reported every month. And the one on the left is those facilities that didn't report every month. And I've drawn the blue line there just to guide your eye to the clear difference. On the left, there's almost a doubling of cases over the 5-year period. On the right, there's a slight increase, but actually it kind of matches population growth. There's an extremely different interpretation of the data depending on once you control for that reporting bias. So as I said, our app displays this for folks so that you can just take the facilities that reported every month. That said, there are some countries where the reporting rate is very high, and when I look at the two charts, there really isn't much difference. So it doesn't mean it's always a problem, but it should be considered a problem unless you actually look to be sure it's not. Right? Now, once we've determined we get our data for the facilities that are reported every month, we then want to do some outlier detection algorithms. I won't go into all of the algorithms that are done here. I'd say that they are somewhat similar to what's included in the WHO data quality tool that's available in DHIS2, with a couple of important differences. One is we also look for seasonal outliers. You may have noticed malaria is something that occurs very seasonally. And so there can be different kinds of outliers, a value that is maybe within the range, but it shouldn't be that high during the dry season. So we can pick those up. The other thing is, so once we flag the value, I can remove them from the analysis. When the WHO data quality tool flags a value, it's just flagged so that someone could follow up on it, but it's still in the data set. It's not removed from what you see. So not only can we remove it, but those censored values are documented so that somebody else looking at my analysis will know what I have removed and why I removed it. And that gets us on to sort of the kicker. Okay, how can we use this data to evaluate our program? So, and here's our final page, the evaluation. So in the chart there, I've removed outliers and I've selected the facilities that reported every month. To me, this is the best indication of trend. And you may notice, I think it's the year 2019, there's a large reduction in the number of cases. And this coincides with a major intervention in this country where they distributed insecticide-treated bed nets. And I'd like to see what that effect was. We can see there was an effect. I want to be able to really document it well. So this app allows you to pick an intervention timeline. The nets were distributed in November of 2018. And now, because you can see, I could sum all that data, but there's this seasonality, and with some packages that are available in R, we can look at that time series data in a way that's a little more sophisticated than just saying, well, how many total cases were there in a year? So that said, there are many actual different models that can be run, and there we go. This will allow you to run those models without having any direct knowledge of how to code them. This will run them for you. And then once you find a model that seems to fit the data well before your intervention, we then run that same model on the data leading up to the intervention and predict what we think we would have seen, a counterfactual, had we not had an intervention. And the difference between, that's the dotted black line there, the difference between the dotted black line and the red line, the actual data, is the impact of our intervention. And in this case, minus 39%. It's very well documented that way, and controlling for all the potential errors. Even more so, we can split this data by the type of intervention. I said there was a bed net distribution campaign, but as it turns out, it was a little more complicated than that. There was one district that did not use nets, and they used indoor residual spraying as well. They experienced a 52% reduction. That's really great, but it's a super expensive intervention. We can't afford to do it everywhere. And not only that, by looking at it by month, we can see it only lasted for about 6 months. It didn't last all year. Whereas with a newer net that's called a PBO, insecticide-treated net, it had a 54% reduction, and it lasted an entire year. Our standard nets, the pyrethroid-treated nets, are starting to lose their effectiveness. Darwin was right. The mosquitoes evolve. They keep sensing the same insecticide time and time and time again, and they get resistant. And so that net originally would have been maybe a 50% reduction, and now it's only a 28% reduction. This helps us verify or support why we want to pay more for a different net that has a greater reduction. And then there was a couple of districts that actually had both and also saw a significant reduction. Okay? So that's the kicker. That's what we want to get to. So I'm going to wrap up here. That the data that's in DHIS2 is just fantastic basis for evaluating program implementation and effectiveness, but the uncorrected data that comes by itself isn't sufficient for doing it. And so there's external apps, or is one, that can be used to add those missing features and extend that capacity. This app is available. That's a GitHub repository that has all the R and Shiny code that I used for it. I want to acknowledge a number of the folks in the field who have helped me use this. Every country is just a little bit different, and so you can find, oh, it didn't work, and had to fix things. So it's been super helpful having those folks. And I actually spoke a little bit faster than I expected. So I want to give you, I had time for one more example. That was pretty good. This has just been happening the last couple of weeks. There was one of our countries, now the larger context, the World Health Organization and numbers are really decrying that we are not making enough progress in malaria, that the cases overall have really not come down. It's whether or not they're going up or not, but they haven't fallen the way we would like. And here comes a country, as you can see that there's a spike there of cases in 2020, but then very few cases at all in 2021 and 2022. And then the preceding years, you see stuff's all over the place. So, I mean, that's encouraging. We like to see the cases, but come on, let's be skeptical here. I mean, we're not going to go to WHO and say, oh, look at what the difference we're doing. That's great. Because they say, wait a second. Maybe that's due to lack of reporting. Maybe the facilities stop handing the data in. So there you go. Yeah, makes it look like your cases are way down. Or maybe this is post-COVID. People stop going to facilities. So we're not detecting the case. They still had the malaria, but they're not getting treated. And that would be particularly bad. Or maybe they're getting to the facility, but they're stocked out of the test kits. And if they don't have the test kit, they can't report a confirmed case. So again, that could be a crisis as well. So what's really going on? Well, we put the data in through magic glasses. First step is separate out the data by those facilities that reported every month versus the rest. And you notice that even those facilities that reported every month, there's still this huge decline. So I can't say that decline is because they weren't reporting. Those are the facilities that report every month, even during that time period. So this is not a reporting bias. There is a real decline in the number of cases. Now, that said, it still could be due to a care-seeking issue. Are people going to the facilities? So we use DHIS2 data to download the first attendance data, outpatient attendance data. And when you do that, you do see, not surprisingly, in 2020, when the pandemic came and there were some shutdowns, there was a huge drop in attendance. But now back to 2021, 2022, there isn't much of a drop. There is historically a decline. It's showing about 11%, but it's nowhere near the decline in the total number of cases. So conclusion is that decline is not going to be explained by a drop in care seeking. Okay. And lastly, we have an index that we use that adjusts for lack of testing. We say, okay, if you didn't test all of your febrile patients, we're going to adjust up your number of cases. I won't go into the details for that, but it's something called the adjusted, corrected, confirmed cases. And when we take that data and display it that way, you can see that there is still a decline even after adjusting for the potential of not testing every patient. So this appears to be a real decline. Now, we don't know the exact nature of it. I hope it's a true, but we have at least been able to rule out now really the main concerns. It wasn't a lack of reporting, it wasn't decreased care seeking, and it wasn't decreased testing. And you compare now, fatal. Oh, well, there it is. Can you show up the last slide? Just make that bigger. So, as you can see, what I had on the last slide was the original raw data versus, next slide. There you go. So the top one I put confirmed, that's the so-called raw data that came from DHIS2, where there are spikes, there's down years, it's all over the place, and then it comes down. But after we do some of our adjustments, there was a drought year in 2016. But aside from that, it now looks as if there's almost a sort of oh, darn it, the last one. Okay. There is a gradual decline over time that would make sense and would suggest that this is a potentially real decline in malaria cases attributable to the program's interventions. Okay. Thank you.